We're going to talk about the end behavior of rational functions, and this is more general than horizontal asymptotes or even oblique or slant asymptotes. This is just saying, what do we know as x is going off to infinity or negative infinity? Is our graph going upwards or downwards? And how do we find that? So, if we have a rational function, we have a polynomial divided by a polynomial. And it turns out to find our end behavior, all we need is the leading term of each of these. So the leading terms of p and q, we'll say those are a x to the m and b x to the n. And all you need for the end behavior is to divide these two things. Okay, divide the leading term of p by the leading term of q. And that reduces to this thing right here. Okay, and our rational function has the same end behavior as this thing. Now, all that means is if this is going, up to the right and down to the left, then that's what this rational function will do. It doesn't tell us asymptotic behavior, it just tells us whether we're going off to positive infinity or negative infinity, or to some number on either side of the graph as x goes to infinity or negative infinity. Now, we can get a little bit more precise than this and talk about asymptotic end behavior. Okay, and this is where we can do a long division. So if the degree of the numerator is larger than the degree of the denominator, then by our division algorithm, we can write the rational function in this form: a of x, which is our quotient, plus, and then b of x, which is the remainder, divided by c of x, the original dividend. So this c of x is actually going to be q of x, okay? But that doesn't really even matter. What matters is this a of x right here, because the degree of b of x is smaller than the degree of c of x, which means as x goes off to infinity or negative infinity, this thing goes to 0, which means that our function gets closer and closer to a of x. So this says that for large values of the absolute value of x, meaning positive infinity to negative infinity, the graph is asymptotic to y equals a of x. Now, of course, if a of x is a linear function, then we call it an oblique asymptote or a slant asymptote. A of x could be 0, in which case, we just have y equals 0 as the horizontal asymptote, or a of x could just be some number, any constant, and that would be a horizontal asymptote. So this is a more general form of how to find an asymptotic end behavior of a rational function.